Okay guys, so today's lesson is going to be on the new unit, which is simplifying radicals, which again, you probably did back in Algebra 1 a little bit, okay? So when we're simplifying radicals, specifically we're talking about square roots, okay? The most important part is knowing your perfect squares, which they don't need to be memorized because all you have to do is just square out your numbers. So if you do 1 times 1, you get 1. 2 times 2, you get 4. 3 times 3, you get 9. 4 times 4, you get 16. 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. You could keep going, but you at least have up to 100 written down on your paper, okay? So when you're being asked to simplify, there's a few kind of types that you'd be asked to simplify. Okay, so to look at some examples, right? Let's start with, what if you're given a really big number, like 256, okay? Well, before you even determine how you're gonna simplify this, the first thing you should ask yourself is this a perfect square? Now, again, my list only goes up to 100, but what I have here is my trusty little calculator. Let's just type in the square root of 256 and see what we get. We do get just a plain old 16, which means it is a perfect square. That means 16 times 16 is 256, right? So if we're asked to simplify to square root of 81, again, 81 is on our list, so we know it's a perfect square. Again, if you forget, type in the square root of 81 to see what it simplifies to be. It simplifies to be just 9. And perfect squares will do that. They simplify to just be a number, not a big, long, crazy decimal. Now, this time I threw a 2 in front. Always understand that just like if this were 2x, the operation is multiplication, this is still multiplication. So this is 2 times 9, which is just 18. Okay, so it doesn't matter how many you have to simplify. If I have 3 rad 25 minus 6 rad 4, again, as long as these numbers are on the list, I can do the math, right? So this is really 3 times 5, because 25 is a perfect square, it's 5, minus 6 times 4, 4 is a perfect square, it's 2. This is the same thing as 15 minus 12, or 3. Now, again, because we're dealing with only perfect squares, what I could have also done is type this entire thing into my calculator in one step. And do you see we still get the same thing? We get 3, okay? All right, so what I want you to do is take a second, okay? And I want you to try, either you could type these into your calculator or give it a try if you don't have. I want you to simplify the square root of 196, and I want you to square root 2 rad 36 plus 3 rad 100. Okay, so you should have gotten, again, first things first, if it's too big, type it into your calculator, bam, it is perfect. It's 14. Here again, if you do it out by hand because you don't have a calculator, this is 2 times 6 plus 3 times 10, which is 12 plus 30. Final answer, 42. Okay, so far so good? Okay, now, what if it's not a perfect square that you're given a question where you're asked to simplify? That's where it's gonna get a little trickier when it's not a perfect square. So an example of that would be, let's say it's rad 27. Okay, so if I look on my list, rad 27 is not, I have the number before, I have the number after, which means rad 27 isn't a perfect square, okay? And I can confirm that because if I type in rad 27 on my calculator, you see I get this big, long, crazy decimal? Okay, that means it's not a perfect square. So that means, unfortunately, we can't use our calculator to do the work for us. Okay, so here's what we want to do, okay? We want to break rad 27 down into a multiplication of radicals. Okay, when we need to think of two numbers that multiply to be 27. Now, for a lot of numbers, there's going to be multiple numbers that multiply to be 27, okay? Sometimes the hardest part is figuring out what multiplies to be the number. So I have a little trick here because you know me, I always have tricks on the calculator to do. we're gonna do 27 divided by x, okay? So if I do 27 divided by x and I go to my table, it's gonna give me all the numbers that multiply to be 27. Now, the only ones I care about are the whole numbers. So do you see we have 1 and 27? And then we could skip this one because it's a decimal. Okay, we go down to 1 and we have 3 and 9. Now, again, what I'm looking for in this Y column is one of these numbers on our list on the side here. And do you see, so our first whole number 27 is obviously not on the list. I keep scrolling down until look at the next whole number and it's 9. If 9 is on that list, I'm gonna stop. This is the pair of numbers I'm using. I'm using that 9 and the 3. Now, I will put the bigger the number, I'm going to mix up the order of this. I'm going to put the 9 first and the 3 second because 9 is the one that's on my list, right? And now all I'm going to do is simplify what I can simplify. The square root of 9 is one of our perfect squares. The square root of 9 we know is 3. So I'm going to rewrite this as 3 times rad 3. Now, if you go back to before, when we typed in rad 27, we got this big long decimal. If I type in 3 rad 3, which is what I just simplified this to be, do you see I get the same big long decimal? So that's also a clue that I'm on the right track because at least they're equivalent. And hopefully I've chosen the simplest one I can, okay? All right, so let's look at another example. So let's do it for, okay, the square root of 50, let's say. Okay, so the square root of 50. So again, if I'm not sure what multiplies to be 50, I'm going to put in 50 divided by x and I'm going to go to the table. And I'm going to start, and again, I'm going to scroll through this y column looking for the biggest number. And again, just keep scrolling until you hit a number on this list. So 50 is obviously not on this list, but bam, I hit 25 right on my list. Okay, so this is the pair of numbers I'm using now. I'm going to use the 25, which is on the list. And what's next to that was 2, because 25 times 2 is 50. But I can rewrite this 25 as 5 times rad 2. Again, if you were checking decimals, okay, they would all work out. Okay, one more example here. Okay, 32. Okay, so again, I go to my calculator, okay, and I type in 32 divided by x, okay, and I'm going to scroll down. Now, the one thing you'll notice about 32, okay, so if you start to scroll down, you see, again, this is the easiest thing you could do is if you type it in every time, keep scrolling until you hit a perfect square. You do hit 16. You don't need to scroll anymore, but keep looking. If you keep scrolling down, do you see you actually hit another perfect square? Down here is also on the list. So 16 and 4 are both on my list, okay? Here's the thing. You always want the biggest perfect square. You want to pick the biggest one. So that's why if you use your calculator, you see your calculator starts at the biggest number and it keeps going down. Just check every whole number and see if it's on this list. The first one you get will always be the biggest one. So I need to use 16 and 2. And I get rad 16 simplifies to be 4, so I get 4 rad 2 as my final simplified answer. Okay? All right, same thing goes if you have numbers. Well, actually, let me give you one to try first. Okay, so why don't you try? Okay, so for you, I would like you to try. Let's try the square root of 96. And I would like you to try and simplify the square root of 48. Okay, so why don't you take a second and try those two. Okay. All right, so let's see how you did. So again, if you are typing in, you're gonna type in 96 divided by x. Gonna go to the table, again, 96, so 48, not on the list. 32, not on the list. 24, not on the list. That's a decimal, I ignore it. I gotta go all the way down here until I see a number on the list, which is 16. So the number next to it is 6, which means this breaks into 16 and 6. And then I have to go one step further. The square root of 16 is 4. So that one simplifies to 4 radical 6. Okay, for 48, again, if you do 48 divided by x, and you look at the table, 48 not on the list, 24 not on the list, but there we go again, 16 on the list. This time it's 16 and 3, okay, which is going to simplify to 4 radical 3. Okay, so it's always that outside number you're going to be simplifying. Okay, one more thing you could see a number in front. So you see here, I have a 3 here and a rad 200. Okay, so if you see that number in front, don't worry about it. It's just going to keep coming down until the very end. So this 3 comes down. For the 200, I'm looking for my 2 rads. So again, I'm going to do 200 divided by x. I'm going to scroll through the table, not a perfect square. Boom, 100. That's on my list. It's 102. So I'm going to put 100 in here. I'm going to put 2 in here. So again, we're going to simplify that, but we still have this 3 in front. So 3, the square root of 100 simplifies to be 10. Here is where the 3 finally affects the answer. So you see now on the outside, I have 2 whole numbers. So technically this says 3 times 10 rad 2. So I am actually allowed to multiply those because they're both whole numbers now, not radicals. So I get 30 rad 2 as my final answer. Okay? So over here, why don't I give you one to try? Can you try 5 times the square root of 12? Okay, so 5 times the square root of 12. So I'm going to put in 12 divided by x. Going to go to the table. So again, 12, not a perfect square. 6, not on my list, but there we go. 4 is on my list. So it's 4, and what's next to it is 3. So that's 4 times 3. So I bring down the 5. This becomes 4 and 3. The perfect becomes 2, right? So this is 5 times 2, rad 3. So I get 10 rad 3. That should have been your answer for that one. Okay, so that's simplifying square roots with numbers. The second component to this is simplifying with variables. Okay, so when we simplify with variables, it's a little bit different. Okay, it's actually a little bit easier when you simplify with variables. So when you simplify with variables, so like just like before, you have to think of your perfect squares. So we're just going to use x as our variable, but it could be any letter, a, b. Okay, so my first perfect square would be x times x, which is x squared. My second one is going to be, okay, again, because that's x times x. My second one is actually going to be x to the 4th, because that's what I get when I multiply x squared times x squared. My next one is going to be x to the 6th, because that's what I get when I multiply x to the 3 times x to the 3. Because you have to remember that when you multiply exponents, you have to add the exponents. Whenever you're multiplying with exponents, you add the exponents. So this is 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. So the next one is going to be 4 plus 4 is 8, right? So on and so forth. The next perfect square is going to be x to the 10, then x to the 12. So what you'll notice here is your exponents are perfect, right? If you notice about all the ones that are perfect squares, do you notice that their exponents are all even? Okay, so if they're even, they are a perfect square. Okay, which means if I'm asked to simplify anything that's even, so again, I could continue my list, but if I'm asked to simplify, let's say x to the 20, okay? Well, because 20 is an even number, I automatically know it's perfect, okay? So all I'm gonna do is, so what you'll notice is the relationship between when it's inside the radical to outside. Do you see? 4 simplifies to 2, 6 simplifies to 3, 8 simplifies to 4, 10 to 5. What you'll notice is the exponent on the inside, when it goes to the outside, it just gets cut in half, right? Divide 4 in half, you get 2. Divide 6 in half, you get 3. So since 20 is an even number, I know it's going to simplify to just be x to the 10th, because that's what I get when I cut 20 in half. It doesn't matter if I have more than 1 under the radical. So let's say I have x to the 18 and y to the 30. Because 18 is even and 30 is even, we cut it in half. So this is just going to be x to the 9 times y to the 15. All you have to do if it's even is cut it in half. Okay, so this one, even I could throw in a number in front if I want. Great. Okay, so let's make this a to the 50th. Okay, so again, the numbers, we're going to deal with what we just did, 25. So if we go back to this page, do you see 25 is on our list? That's one of our perfect squares. So 25 just simplifies to be 5. Because 50 is perfect, all I have to do to square root it is cut it in half, and I get a to the 25. Okay? All right, so let me give you guys a little bit of time to work on these. Okay, so let's say I ask you for a to the 22nd. In this example, let's do x to the 10th, y to the 40th. Let's throw in a z here, z to the 4. Okay, so let's see what you got here. So again, these should be pretty quick. So again, exponent is even. Get it out of the rad by just dividing the exponent in half, right? So that would be simple. Just do 22 divided by 2 if you don't feel like doing the math yourself. Okay, here, since all 3 of these are even, we're going to cut it in half to 5. Cut it in half to 20, cut it in half to 2, box it up. You're done. So then the next question that should be on your mind as well, what if it's not even? What if we get something that is, we're given an exponent that's not even? Well, it's actually not so bad either. So let's say I get x to the 7th, right? So x to the 7th is not a perfect square, okay? So just like before, where we were talking about, let's break it up into 2 radicals, right? A perfect rad and a non-perfect rad, okay? So here's the thing. So it's like, all right, what's the biggest one on this list? So here's the thing. So 7 falls right in between 6 and 8. So you always have to go smaller. So do you see that's going to be right at this x to the 6? So all I have to do is just drop it down 1, and now I made it even, okay? But because I'm dropping it down 1, that also means there's a leftover x. So drop it down 1 to an even, leftover x. Now, the even part, I can now square root. And remember, the way we square root variables is just by cutting them in half. So the x to the 6 becomes x to the 3. The rad x just stays by itself. Okay, let's try that again. So if I have a to the 23rd, okay, so again, a to the 23rd, it's not even. So I'm going to do the same thing. Drop it down to 22. All I have to do is drop it down 1 and it becomes even, and then there's going to be a leftover a. So there's only always going to be just 1 left over. 22 is even. I can cut it in half to 11, and that's my answer. A to the 11th times rad a. And again, it does not matter how many are in here, right? So if I have, let's say, x to the 31 and y to the 13th. Okay, so both are odd. Okay, so here I'm going to break them down. Now again, I'm going to just do 2 big radicals. So for the x to the 31, I'm going to drop it down to x to the 30 with a leftover x. For the y to the 13th, I'm going to drop that one down to a y to the 12th with a leftover y. Okay, now all this even stuff, I can square root now by just cutting the exponent in half. So 30, when I divide it by 2, I get 15. The 12, when I divide it in half, I get 6. And then just leave that leftover there. Okay, so what I would like you to try is, do me a favor and try these. Okay, so let's do a to the, let's do 9. Let's do b to the 21 times c to the 19th. Okay, and try those 2 for me. So remember, there's only one letter in here and it's odd. So I'm going to drop it down 1 to the 8th with a leftover A is going to leave me with A to the 4th and a rad A. This one, B to the 21 is odd, so it's going to go to the B to the 20 with a leftover B. C to the 19 is odd, so it's going to go C to the 18th and a leftover C. Second step is cut your evens in half to B to the 10, C to the 9, and now it's no longer in a rad with a leftover B, C. Okay? All right, last thing I want to do is just combine, do a little combo here with some letters, some numbers, and a little bit of everything. Okay? So here we have, I would like to do, let's look at this example. What if I have two different letters? One of them is even and one of them is odd. Okay, so that's not a big deal. Okay, what I would do is, since the even stuff can automatically get cut in half, it's perfect. What I would do is, if you see an even one in there, get it out right away. Cut it in half and get rid of it. Just cancel it out. Now I only have to worry about fixing the B. So the B, I need two radicals for the B. The B, I'm going to drop it down to B to the 12, and then I'm going to be left over with a B. So this A to the 5, I don't have to do anything with it because I already cut it in half. It's out and I'm ignoring it now. All I'm going to do is bring it down. I'm going to now fix my even now that I made to B to the 6, and then I have a leftover rad B. So it doesn't matter what combination, okay? Let's do a combo here. Let's say I have A to the 6, I have B to the 17, and I have C to the, I don't know, let's make it 20th, okay? So again, quick look to see what you got. Do you have evens? Do you have odds? Okay, any of your evens you could fix immediately. So that's even, I'm gonna cut it in half to A to the 3rd. Not even, that's even. I'm gonna cut it in half to C to the 10. Now I really only have to worry about one radical. So I have B to the 17 becomes B to the 16, okay, with a leftover B, right? Drop it down 1, leftover B. So all I'm going to do is bring down this stuff I already fixed, but joining it is going to be this even exponent when I cut it in half is B to the 8th. Okay? All right, so why don't you try? Okay. Let's do y to the 13th, z to the 30th. Okay, and then you can also try A to the 5th, B to the 7th, C to the 8th. Okay, guys, so here's what we got. So again, just look at what you got. You got an odd and an even. All right, even, get it out. Z to the 15. Odd, drop it down 1, y to the 12th, and y. So here I have z to the 15th, joining it is y to the 6th, staying left over is that rad y, okay? So this one, again, I'm gonna cruise through it. Odd, I gotta work it. Odd, I gotta work it. Even, let's get rid of it. C to the 4, cut it in half. Okay, so we have 2 to work here. So A to the 5 drops down to A to the 4. With a leftover A, B to the 7 drops down to B to the 6 with a leftover B. Okay, so joining this C to the 4 is what I get when I cut these in half, which are A2, B3, and rad AB. You could leave it like this. If it's a multiple choice, these 3 on the outside could be in any order. They usually pop them in alphabetical order, but it's not a big deal. Okay? So last but not least, I could do a combo of numbers and letters, again, like we did before. Again, sometimes, so here you could have, so here's a combo. Okay, so in this combo, I look again at the numbers. So I go back to my number list right here, right? And what I do notice is that 36 is on this list. So again, anything that's perfect, you can fix it right away. So I can bring out that 6, right? So now I don't have to worry about the 36, but a to the 11th isn't perfect. So I've got to make it a to the 10 and a. So joining this 6 is what I get when I cut that 10 in half, which is a to the 5. Again, you just have to look at what you have. So here, if I have, let's say I have 18, okay, b to the 10th, okay? So 18, if I go back to my numbers list, do you see 18 is not on this list? Okay, so I know I'm gonna have to fix the 18. However, the b to the 10 is perfect. So if I want, I can fix the b to the 5. I can make it b to the 5 right away and get rid of it. Now all I have to do is worry about simplifying the 18. So remember, the way we simplify numbers is we put 18 divided by x and we go to the table. So cruising down the list, you see the very first number I see is on my list. 9 is one of my perfect squares. So I'm going to rewrite this. 18 is 9 times 2, so joining this b to the 5th is the square root of 9, which is 3. I'm just going to put it in front of b to the 5th because we usually put numbers in front of letters. Okay? So why don't you try these last two? This is all we got for the day. Actually, maybe I'll just give you, let's do two. So let's do, I'm going to give you 75 a to the 3rd. Okay, so why don't you just try that one? Okay, so with 75 a to the 3rd, first thing you'll notice is if you're looking at your list, 75 is not on your list. So you're going to have to go to your calculator and put 75 over x. The other thing you will notice is that a to the 3rd is odd. So neither of these can be fixed right away. Okay, so what we're going to do is scroll through our lists. Okay, so that's a decimal. There we go, right? First number, 25 right there, that first whole number is a perfect square. So that means when I open up my two radicals, for the 75, I need 25 and 3. Now for the a to the 3rd, it goes down to a to the 2nd and a. So you'll notice I put all my perfect stuff together and then I put all of my leftover together. Okay, so this 25a squared is just going to simplify to be square root of 25 is 5. A squared cut in half is a to the 1. You don't have to put in the 1, or you can if you want, a to the 1. And then this leftover always stays leftover. Okay, guys, that is simplifying radicals.